Hey guys, welcome to the product rule. Okay, so today we're going to be talking about derivatives, and we've already talked about some of the basic rules. We started with the power rule. Now you move on to the next one, which is the product rule. The product rule helps us deal with the derivative when we're multiplying two different functions together. Okay, so d dx of that combination of two different functions being multiplied is equal to the f times g prime plus g times f prime, which to me I hate. I look at it as this way. You take the first times the derivative of the second plus second times the derivative of the first. So first times the derivative of the second plus second times derivative of the first. Okay? We use this rule to find derivatives of the products of two functions. Try not to confuse this with the chain rule. We'll get into that later on. Okay, so let's look at some examples. And although we're doing, we have three examples, the second one I love the best, where it's two distinctly different functions. You have the x squared function times the sine function. So there's where we're looking at our two different functions, okay? So when we're going to take the derivative, so let's look at these. So y equals the quantity 2x cubed plus 1 times the quantity x to the fifth minus x. So if I go ahead and I want to do dy dx, okay, I can simply take the first function, which is 2x cubed plus 1, times the derivative of the second, which all I use is the power rule. This becomes 5x to the fourth minus 1. So we're assuming you have some knowledge here of the power rule. So we have first times the derivative of the second plus the second, x to the fifth minus x, times derivative of the first, which is 6x squared. Okay? Now you could multiply this through if you wanted to, right? The derivative of the constant. But essentially, if you're looking just for the derivative, there it is. And that's going to be a lot to multiply this out and simplify in this too. You're just not going to do it. There's the derivative. End of story. Okay? Let's look at example number 2. This one's a little bit easier. So we have y equals x squared times sine of x. Okay, so if you really wanted to do this, you could say, okay, here's my first function, here's my second, if I wanted to label those. And we have to use the notation dy dx now, taking the derivative of y with respect to x. So you have your first, which is x squared, times the derivative of your second. The derivative of sine of x is cosine of x, plus second, which is sine of x, times the derivative of the first. The derivative of x squared is 2x. Okay? I can rewrite that as x squared cosine of x plus 2x sine of x. Now you might want to factor an x out. It's just not necessary. You can just leave it there. We're just finding the derivative. We're just practicing the rule here. Okay? And we have one more example. I like this one. It takes a little bit. And you won't know this if you're in my class yet because we haven't really done trig functions, but I love this one. I had to do it. So I have y equals x over cosine of x. And you might think, well, it's division, so quotient rule, which you could do it that way. But you could rewrite this as y equals x times, well, 1 over cosine of x is just secant x. Okay? So now you take the derivative, dy dx, of, or dy dx is equal to, okay, well, let's take the first, which is x, times the derivative of the second, which in my class you won't know yet. The derivative of secant x is just secant x tan x. Okay? Plus the second times derivative of the first, so secant x times 1. Here, if you wanted to, you could factor out the secant of x, secant x. So you're left with x tan x plus 1. And there's your derivative. So these are just three quick examples of finding the derivative of functions using the product rule. Again, think about first times derivative of the second plus second times derivative of the first. If you have any questions or comments, please let me know, and we will see you next time.